Alright, so here we are back on our setup, and yeah, this time we are not talking about the smartphone, so a web browser that is making an HTTPS request. We are talking about an application that is making an HTTPS request. And there might be a little bit of a difference in there. That's also why I have chosen the spicy title, Is Certificate Pinning Better Than HTTPS? And we will get back to this later on. For now, let's have a look at this one over here. So we've got our smartphone, and the smartphone has now an application, example.apk. And this application wants to perform HTTPS request. Therefore, the backend, this example.com, is now presenting the certificate if a client connects to this one. Alright, we have seen that's absolutely no problem. We just simply present our certificate, and we also install the certificate on the smartphone. By doing this, we should be pretty good to go to inspect, analyze, and manipulate this traffic right now, right? Well, let's see. So the application wants to make this request right now. And the application tells us simply, no. And I mean, wait, what? Why? So we are screaming back to this application over here, hey, you even didn't try to look up the certificate I'm presenting to you right now. And the application simply answers,
yo, even if you have sneakily installed your certificate onto the smartphone, so within the user or the system storage, I even won't trust you right now, so get out of my way.
The last part, I mean, should have been a little bit deeper voice, but I guess we get this point of this application. This application is telling us, get out of my way. And this application, so it doesn't trust the system storage or the user storage regarding to the certificates. We can think of this as the most paranoid application we are facing right now. Alright? Okay, so how is this application then verifying if it's connected to, a fake system or the real system? Well, there are two options for the developer right now to achieve this over here. The first one is the developer simply includes the certificate into the application itself. So within the assets or the raw storage or whatever the developer wants to put this into this right now. So if this certificate has been included into the application, then the developer is making a web service request, an HTTPS request, and it proves if this corresponding certificate, so the endpoint, matches this certificate over here. There are some key features in the certificate that can be verified and that cannot be faked by an attacker. So that's the first approach, how the developer can verify that the endpoint is really the server of the developer, not something sneaky like an attacker over here. Okay? The second approach is regarding to some parts in the certificate that cannot be faked as an attacker. For example, the signature. The signature is being complexly generated. There's a lot of stuff involved in doing this, and there's a lot of cryptographic stuff that verifies that this signature over here cannot be faked by an attacker. So an attacker cannot have its own certificate and the same signature. This type of attack is named hash collision, and yes, it has been proven in the past that this has been successful, but only theoretically and only for weak algorithms like SHA-1 or MD5. If the developer has chosen a proper algorithm, then this cannot be done right now. It might be possible in 10-15 years when we have some fancy quantum computers, but not right now. So the developer can rely on the signature. If this value is represented in the certificate, then it's the certificate of the developer. So that's the second approach, how the developer can verify if this is the corresponding endpoint. And now, let's get back to the spicy question. Is this approach now better than HTTPS? I mean, even if the attacker can place the own certificate into the system storage, the application doesn't accept it. So at least it sounds to be more secure right now, isn't it? Well, I do not want to go too deep into the discussion, but we have to consider some things. Installing a certificate on a smartphone over here requires a lot of tasks being involved. This is something that doesn't happen suddenly, so there are a lot of barriers in our way to perform this task. And we can now argue that we are also having the same barriers regarding to certificate pinning. So an attacker can bypass the certificate pinning, and you will also see how we can do this later on. And this means no matter if you want to patch certificate pinning on an application over here or installing a certificate on the smartphone, there are some really strong security concepts in our way that needs to be bypassed, and the effort might be the same. But to be honest, my point of view is the following. Certificate pinning doesn't weaken your application security, and therefore it also doesn't hurt implementing it. It also doesn't mean that it's now being more secure than a normal HTTPS connection, but in total I would recommend implementing a certificate pinning. So that's my point of view, but of course this hasn't to be the correct view. So at the end, I mean, it goes down if you can represent this topic with your opinion logically to the customer. Then, I mean, everything is fine about this one. So yeah, if you have any question regarding to this topic, then yeah, please write me a message. I'm super happy to discuss this together with you. Alrighty? Okay, nice. So now we have seen what certificate pinning is. And we have seen that simply installing our certificate on the smartphone doesn't solve this issue right now. Therefore, let's have a look how we can bypass it. Alright? Okay. And the nice thing about this one is, if we talk about this one, we already figure out what's the solution. So how can we circumvent this certificate pinning over here? And let's recap this a little bit. The application doesn't trust the system or the user storage of the internal certificate storage of the smartphone. Okay, absolutely fair. Therefore, the developer has to add its own certificate into the smartphone application, like this one over here, or the developer has to hardcode the fingerprint of the correct certificate into its own application. So the bypass for this one is, I guess, replacing those values. Absolutely, and this is exactly what we want to do. So we decompile this application, and then first we have to figure out how the certificate pinning is being established. If it is a certificate, we might spot the certificate directly in the assets or raw directory. And if it's the fingerprint, then we will also see how we can get into this point very quickly by reversing this application for certain keywords. No matter what it is, it has to be included in this application code. So our approach is simply decompiling, reversing, and then patching this application code. And you know what? We are now Smiley experts, so this is absolutely no problem for us right now. Nice, isn't it? And therefore I would suggest let's finish this theory part over here, and in the next video we have some hands-on exercises. I will introduce you these two types of certificates pinnings. I have written some really amazing apps regarding to this one. Okay, they have a little bit of a lack of UI, but regarding to the implementation, that's exactly what you face outside here. So in the real world, these are now two real world applications. Therefore, I'm looking forward to see you in the next video.